All right, hey, we're entering a new chapter, and every time we move, man, we expand our knowledge with matrices. And unbeknownst to us in the background, what's happening is we're building more and more structure and actually building a different world where algebra occurs, arithmetic occurs, and all that. So let's take a look at what the main topic is here. They're talking about how to multiply matrices together and what's the story, okay? So we're going to talk about, let's find, look at the notation here, A, B. What that means is you're gonna, it's the product of matrix A with matrix B. Okay, and how in the heck are we supposed to do that? So what we ought to do is let's put them side by side and then visit, actually we're going to visit the definition. So we'll just say AB, A times B is this guy times this other guy. Okay, so they're different sizes, and I'm wondering if it's possible to multiply them together. And it is, because by definition, now here comes the definition. Definition says, okay, by definition, you're going to create a new matrix. Okay, and this new matrix is going to be, if you give this guy a name, you're going to go, okay, it is A times B1. Okay, what's B1? This column is B1. What's A? It's all of that. Okay, and then the next column, well, it's the same thing, B2. You're going to go A times B2. Okay, that's the definition. So I decided, you know what is that all about? I'm going to draw a great big thing. It's going to be equal to big old matrix, let's say, and let's put in A, 2, 1, -1, 4, 3, 8. And let's put in B. B is 5, -3. Now you notice a column is really a vector, isn't it? We've been studying that. Okay, and then the other column is 2, 1, -1, 4, 3, 8. And times the other column of matrix B, which is 1, 4. You know, when you first in algebra go over the distributive property, they have this funky definition, kind of makes you crazy, and then you learn the fast way. And we're going to do the same thing in this video. But look at this, what we have here. Yes, I'm going to make you crazy. What I'm going to do is revisit the definition of multiplying a matrix with a vector. So what we have here is 5 times the first column of A, 2, -1, 3. And then we'll go -3 times the second column, 1, 4, 8. And when you put those two together, guess what we're going to get? We're going to get a 3 by 1 vector, aren't we? And that's the first column. And then the same thing over here. We're going to go 1 times 2, -1, 3. See the structure and how it kind of fits together nicely? And then 4 times 1, 4, 8. And a big old matrix there. And then let's just do the math now, and we'll get this guy done. It looks like we're going to have 10 minus 3 is 7 here. Minus 5 minus 12 is minus 17. I'm looking right here right now. And then 15 minus 24, I think, is -9. Okay, that's the first column. Second column. So it's like you're taking each column of the second matrix, which way do I go? The second matrix, and treating it like vectors times the first matrix, just like we have defined in chapter 1. Okay, the second column is over here is 2 and 4 make 6. And then we have -1 and 16 is 15. And then finally we have 3 and 32. It looks like what I'm getting is a 35. Is that right? Okay, I've got 3 and 32 is 35. Okay. All right, and that's the result. This is A times B. Now, before I sign off, take a look at this. A was, well, look at it. It's 3 by 2. B is 2 by 2. So it's defined, isn't it? The product is defined. We still do it that way with matrices as well as vectors. And then look at the outside. The size is 3 by 2, and yeah, that's what we got. My last comment on this is what we have to talk about. What about B times A? Is A times B equal to B times A? Abba, take a chance, take a chance. Can you do that? And the answer is, with matrices, not usually, no. With numbers, yes, 5 times 2 is 2 times 5, no problem. And that's a stronger group in algebra. But this guy, if you try to do it, what you're going to have is that 2 by 2 guy, which is 5, 1, negative 3, 4. And then he's going to multiply with A, which is these guys, 2, negative 1, 3, and 1, 4. Did I say he's going to multiply? You can't multiply. Because look, this is a 2 by 2, but over here is a 3 by 2. So if I try to do it, if I try to do this, what I'm going to do is I'm going to go, oh, I'm going to try to get this big old matrix, and I'm going to go 5, 1, negative 3, 4. And then I'm going to multiply by this guy, which is 2, negative 1, 3. But what we know from the past is 2 by 2 times a 3 by 1 is not defined. It's not defined. Okay? I said that was the last thing, but it really isn't. So I'm gonna I'm gonna look at this another way. So, all right, let me go back up here, and that's the definition. All right, so by definition, okay, that's great, that's fine. Here's how people normally pretty much do it. They go, okay, so I'm supposed to first of all 3 by 2, 2 by 1. Okay, I'm gonna do the. I know it's going to be a matrix. What size is it going to be? Okay, it's going to be a 3. Oh. 3 by 2 by 2, 3 by 2. All right. So I'm expecting a 3 by 2 when I do it. And here's how people usually do it. They just basically go this dotted with this, if you will. And they do it in their heads. They go 10 minus 3 is 7. Then they go to the next column and they go 2 and 4 make 6. Then they go down a row and continue. And so if you go around here, you've got negative 5 and negative 12 is negative 17. And then you've got negative 1 and 16 is 15. You get the gist, right? Let's finish it. We'll go in blue this time. So 3, 8 goes through now. We go here and here. And so we got 15 minus 24 is negative 9. And then we've got 3 and 32 is 35. It's a lot faster, okay, to go row to column, row to column, row to column, row to column, than to write out that entire thing. But I just wanted to show you that that's the definition and that's the structure. Pretty good stuff. That's the end of this video, and carry on and continue studying, you guys. We will end this one now. All right.